Here's a fact. Engineers make decisions day in, day out. Whether it's designing critical components of a novel medical device, specifying mechanical properties required for a spacecraft subassembly, or trying to reduce variation in a manufacturing process, engineers are expected to make decisions as it's a crucial element of their job. So, the question is, how does one make good engineering decisions? More importantly, what makes a good engineering decision? I have some thoughts around these questions, some concepts that seem to have worked for me, so let's dig in. Knowing what's important. Regardless of the activity the engineer or the engineering team is undertaking, understanding the critical pieces of that activity is crucial. Only when one has understood the critical pieces, that is, things that really matter, can one plan and execute those activities successfully. Of course, some of this comes intuitively, but some of it requires deep investigation and analysis, such as problem solving, root cause analysis, and the likes. Bottom line, understanding what is and what is not important for your design, process, system, or whatever it is that you're working on is one of the elements of good engineering decision making. Gathering and leveraging data. There's a quote by W. Edwards Deming that goes like this: "In God we trust, all others must bring data." Deming was one of the great quality gurus to ever walk this earth, and this quote of his really hits home. Needless to say, good engineering decisions are factual, or in other words, are based on data. Whether it's measurements, calculations, estimations, or simulations, gathering and analyzing data about the problem of interest is a crucial part of making an engineering decision. One thing I want to add here is that in gathering, analyzing, and applying data, logic should still prevail over solely relying on calculations or statistics. Understanding relevant regulations. Regardless of the industry you're in, there are certain standards and regulations you just can't circumvent and must follow. Just look at AITF 16949 for automotive or ISO 13485 for med device. However, understanding these regulations and standards doesn't just mean being able to recite them. It means understanding the intent of the standard. Most standards and regulations are a framework rather than black or white orders. Yes, you'll most probably find some black or white clauses in a standard. Shall, shall not, must not. Sound familiar? But remember that most of them leave room for how one may be able to meet them. The engineer's role here is to understand the intent of the standard and come up with a way that both meets the standard and best applies to their particular problem, organization, and situation. All in all, as long as you apply critical thinking to each of these three elements, you're one step closer to making good engineering decisions. That's it for today. I'd love to hear your thoughts in the comments section.